actually happening. View, this is the full screen slideshow. Yeah, let me get a watch out. Do we have paper and pencil here?
No.
I've got a pencil. We need to write down. Here, I've got it. We need to write down people who are going to who agree to review Cha-Cha.
Okay.
Okay, so I've got a watch going. So we do 10 minutes, so then it's noon, and then so we have to stop Yoav at 1 o'clock. And then we have 20 minutes for that.
Ah, okay.
If we do, we've allocated him an hour. So come on in and be ready. We're already running a little bit late, but we're okay. So, but do come in and settle in. Let me just double check.
Yeah, it's very weak, very low.
I was. Okay, welcome. You stayed. We appreciate it. So this is the Ipsecme working group. We are still in Dallas for another few minutes. I'm Paul Hoffman. This is Yaron Sheffer. Some of you might not recognize him except as an email address. He does exist, and his intention is to continue to exist now. So, yeah.
For a while.
Yeah. So let's do a brief status report. So I do. So what's the answer?
I can do it.
Let me just see if. Give me a moment. Let me just see if futzing. Yeah.
Do you want to try my machine?
I'm sorry? Tell you what, let's just use your own.
Yeah.
He has a PC.
I have Linux running on it, but it'll still work.
Yeah, but we don't actually have time for that right now. So running auto setup. That's not it. Yes.
All right.
Oh wait, there's an Apple person sitting right here. Were you guys here when Stuart did it the other day? Oh, okay, fine. Stuart's Minions, excellent. So anyways, let's just keep going because we actually have filled our whole time, and some of us need to leave right at 1:20 in order to not miss our flights. So since we met last in Hawaii, Draft Kivin and Ipsecme signature auth was published as 7427. So we have nothing in front of the IESG. We have nothing in IETF last call right now. The major thing that we have worked on since then was the null auth document. It's done with working group last call. We had a round of changes since then. Kathleen took a look, had some changes. They issued the new draft yesterday, so now it's back on Kathleen's plate. She will review the draft again to make sure that it meets what she thinks it needs to do before it goes to IETF last call. We might even have another round in here. We may not, but the next step on that is we hear from Kathleen. Paul? Although I guess we're going to hear from Paul first. Yeah. Great. Good. Send that to the list, and if you can do that even before IETF last call, that makes IETF last call folks happy. Kathleen?
I was fine with the draft. There was just a little bit of language I wanted to make sure everyone was in agreement with. I was able to talk to Paul and Taro, and it was an important part because the way the audit section read prior was that everything was kind of out the window, but it's only out the window for no authentication, meaning that you wouldn't have all the tracing and whatnot. You still have the trust models on these changes, and I just wanted that very clear.
Sure.
And that's been addressed, and then I wanted to make sure that the working group had discussed this in that way, and that was going to hold up. So just tell me when to hit the go button.
So you can hit the go button, but I figured you might want to look at the diff in 05 to make sure that it actually met what you wanted.
Yeah, so when I hit the go button, it involves all of that.
Fine, yeah, so we are at that state. You can, look at the diff, and if we need to do another round, we need to do another round, but if the diff is good by you, let's go to IETF last call.
Okay.
Great, thanks. Yeah. Yes, you just walked by her, as a matter of fact. Yeah, that's right.
There was one change that we made actually we didn't discuss in the working group, so let me explain it. So there was some text that said that due to the new, due to possibly old assumptions in the code that everyone was updated and you could trace them down, this no longer being the case, you should, quote, audit your code for any hidden assumptions. We got feedback from someone that said, could you please remove the word audit? Change that to something else, because otherwise we need to present a big stack of papers that we have audited this. So I changed the word for that to remove that.
That's just fine. There are certain magic words where people ask us to remove them. Also legal, right? Yes, right. So great. So that is ready, Kathleen, whenever you feel like it. If you have a fairly long plane flight. No. All right. So yeah, whenever that happens, that's great. So then that will go into IETF last call, which means the IESG will probably look at it in about 4 to 6 weeks. And if things go well, it may be an RFC before Prague. So we have one currently accepted piece of we're working on, the DDoS protection, and we did the agenda for, so the agenda for day is what we just did, or a little bit, no, I'm sorry, what we're about to do, since document is your own's, about an hour, and certainly no more, on DDoS protection, presentation, and hopefully discussion. If we don't have discussion, we will ask, are we not having discussion because you're all in agreement or whatever, but, so about an hour on that. 10 minutes on a new draft that there was some interest in the working group in adopting, but not enough to make me completely happy. And we're going to try to make you happier because I think it's a logical thing to be in the working group, but I want to make sure we get enough review. Daniel McGault, again, seems to have these interesting drafts every time from another working group. He'll have a presentation on that. We have 5 minutes allocated at the very end, and then we all run away and try to catch our flights.
Okay, so the focus of this meeting and the main document before the working group is DDoS protection. There was a lot of progress since Honolulu, both by a new version being published and quite a bit of discussion on the list. But in my opinion, in our opinion, the draft is not yet ready for working group last call. I hope it is by the time we have this discussion face to face, some more discussion on the list, and then next revision, we'll see. So Valerie joined Yoav as co-author. They're managing the draft on GitHub, and it's very important that although the diffs are public on GitHub, discussion of new text should only happen on the mailing list. So this has been the case so far and should continue to be so. The latest revision of the draft, or maybe the one before it, changed puzzle from hash to PRF, so it's the same PRF as negotiated for the IKSA. We had quite a bit of discussion, and Yoav actually ran some tests on the time that clients should spend on various hardness levels of puzzles. In my personal opinion, hats off. I think we should have put more emphasis on deterministic behavior of clients, and this also goes to the next bullet, which is the draft currently allows clients to sort of make up their own mind, like, I need to do a puzzle, and now I'll decide how much time I want to spend on it. I think this, again, hats off. I think this flexibility is either adding complexity to the clients or just not useful at all. And then the latest revision had a lot of new text added, mostly very good text about ICOS and about DDoS for already established IKSAs, which is mostly interesting in the case of null authenticated peers. But the mere fact that we had so much new text means that some more review is needed, both face-to-face today and obviously on the mailing list. So we're doing well. I would like to encourage everybody here to read the draft, to send more review comments, to actively participate in the discussion. Personally, I think we're doing something that's very rare and perhaps the first time that we're adding such strong DDoS protection to an actual protocol. So that's something to be proud of, and let's get it finished well. And next.
So, well, you're doing all the slides, right?
Are there any more?
No, but
No. So next is yours.
So as Jeroen's pulling this up, let me point out that other working groups have assumed cookies in the IKv2 sense are sufficient, and now they're looking at anti-DDoS themselves. DNSOP may be one of those. So to echo what Jeroen said, let's do this really well, if nothing else to save lots of other working group time when they say, this is good enough, and we go, no, we did that actually in 2014 and threw it out or whatever. So, Tiro? Who did? Yeah, okay. Yep. So we may be not only doing the good work, here, but it might be reused later. So.
Yeah, it's sort of working.
I think it's. Oh, now it's. I purposely asked and people said it was.
I guess we could use the other one.
I think the other one is also very weak. Now it's on.
Okay. I'm Yoav Nir. I'm one of the authors of.
Tell me you can hear me then. Sorry.
Of the DDoS draft. Okay, next. So, null service attacks on the IKE responder. Null service attacks on IKE responder aim to exhaust its resources by draft divides null service attacks into several kinds. So, they're always on the responder because although IKE is kind of a symmetric thing, unlike say TCP or TLS, the attack is always on the responder. Multiple initiators attacking the single poor responder. So we're trying to exhaust its resources by initiating requests that either do not complete or are unnecessary. So if the attack is performed by multiple attackers, we call it a distributed denial of service attack. And the goal of this draft is to make these attacks as costly as possible for attackers. So, right. Depending on the point in the protocol for the attacks can be performed either in the IKE SA init exchange, where the initiator, the attacker, sends a single IKE SA init request and never follows through on it. That is trying to exhaust the half-open SA database. The attacker, on the other hand, can continue the exchange or get the reply from the responder and then send an IKE auth request and no more. Or there can even be an attack after the IKE SA is established that could possibly be done by authenticated peers, but is probably more interesting as an attack by null authenticated peers. So IKE session resumption, RFC 5723, can be used to minimize the impact of denial of service attacks. I think, yeah, our draft recommends that even in the face of the attack, when we're sending all sorts of challenges to new initiators, if one of the initiation requests comes with the session ticket, as in RFC 5723, it gets priority and the IKE SA is set up even when there are other attacks on the net. Next. So the original kind of attack that it was the only kind of attack that was in the first draft, and the goal is to exhaust the memory by creating a large number of half-open IKE SAs. The cost is very trivial to the attacker. It's pretty much bandwidth and that's it. Right? The countermeasures, there are several countermeasures that of the discussion on the list is all the time focusing on the puzzles, which is kind of the weapon of last resort. There are certain countermeasures that we expect the responder to deploy well before resorting to puzzles. If for no other reason, because existing initiators don't support puzzles, and we do want them to be able to connect unless we're at that last resort. So the first countermeasure is to limit the amount of half-open IKE SAs that we are willing to accept from a single IPv4 address or a single IPv6 prefix. So in that case, if we limit that to, say, 5, then a single initiator can only create 5 entries in the half-open SA database, and for most implementation, 5 is not that bad. So if that's not enough, then we can use stateless cookies that would require the attacker to use only real IP addresses rather than bombarding us with an endless amount of spoofed IKE SA init requests. So these two have to actually be used in conjunction, otherwise the first protection really doesn't buy you anything. If you're willing to accept spoofed packets, then limiting the amount of per address half-open SAs doesn't buy you anything. If that all fails, then we just turn to puzzles. Puzzles require attackers to consume substantial computational resources, and substantial could be about 1 second of CPU. That's kind of the guiding number. Substantial computational resources to make a request. The hopes that the combined computing power of the attackers is not so great as to overwhelm the amount of half-open SAs that the responder can tolerate. Next. So the puzzles. The way the draft has it currently is that the responder includes a new notification called puzzle along with the cookie that is already in the IPv2 RFC. The puzzle notification contains an algorithm, currently it's a PRF, to be used in puzzle calculation, and that is selected by the responder from the PRF transforms that the initiator had in its SA payload. That's how we assure ourselves that the initiator supports that algorithm. And of course, the difficulty level can be adjusted according to which PRF is chosen. So if a PRF HMAC MD5 is significantly faster to calculate than PRF HMAC SHA-256, then we'd have a slightly different puzzle difficulty depending on the PRF. And the puzzle difficulty level is it's actually the number of trailing bits in the value that the responder calculates, can be set to 0, meaning that the client should get as many as possible. So the client might run the algorithm for, say, 2 seconds and give the best result as its puzzle solution. Okay. And contrary to what Yaron said, in my opinion, giving the client the freedom to choose whatever level they want to do actually makes things more complex on the responder side, not on the client side, because the responder is now getting all sorts of initiations with different levels of puzzle solution, and there's no bar that and everyone that's over that bar gets in and everyone that's under that bar doesn't get in.
That too.
Yeah. So there's has to be some weird algorithm to decide which something probabilistic to decide which clients get in and which don't. So in the IK8 init, the puzzle is given a PRF and the cookie that's also transmitted in the same message, find a key K such that the result of PRF K with the key K and the cookie contains the requested number or the maximum number that you can find of trailing 0 bits. So example with HMAC SHA-256 and 2.4 gigahertz single core i5, that's the thing right there. It takes between half a second to 5 seconds to get 20 bits depending on the cookie. And that's the issue, that's the real issue that we had with that, because depending on the cookie that I randomly generated, sometimes that laptop could find the result in half a second, other times it took 5 seconds. So is 20 bits a good level of puzzle for this laptop? Is it good for one of those phones? Probably not. Okay, next. Okay, so legacy initiators would ignore the end puzzle because they don't have any idea what it is. And with all the extensions that we've made in this group, I think responders and initiators are now pretty well trained to ignore all the weird notifications. So a legacy initiator would act as with tasteless cookies from RFC 7296. They would still have a chance to create an IGSA, and this is the probabilistic part that I said, but their request would be marked with the lowest priority. So anything that solves any bits gets priority over something that is legacy. An initiator that supports puzzles could solve it and restart the exchange with the cookie and the solution, which is contained in a new payload. We call it puzzle solution, denoted PS, and that's the repeated IKSA init request. Okay. So upon receiving the request with the PS payload, the responder would verify the cookie and the solution. If the verifications fail, either discard the message or give the initiator a new puzzle. And then assign a priority to the request depending on puzzle difficulty, the number of consecutive puzzles the initiator has solved, though that does require to keep some state on how many puzzles have gone through, and the amount of time it took the initiator to solve them. So the responder weighs the priority of the request and its current load and either accept the requests, reject the requests, or gives the initiator another puzzle just to send him away to come back later. Maybe then we'll have enough room for him. Especially in case the puzzle appeared too easy. Eventually the request either accepted or rejected, and eventually the client either managed to create a half-open essay or goes away. Yes, Brian.
Hi, Brian Weiss, Cisco. How does since this is a stateless thing, how does the responder know that it appeared too easy?
It could be encoded in the cookie.
Okay.
That it was too easy is, well, by counting the number of 0 bits. If our current level of puzzle is 20 bits and the return and the value returned only had 18, no, that's too low.
So one thing you may, Brian, one thing you may not have noticed between some of the drafts is that the client doesn't have to solve the cookie completely. It can partially solve, and the responder gets to say, yeah, good enough, I just wanted to see if you were around, or you must do, I will only take ones that have done it this far.
And if we set this puzzle level to, say, 20 bits, I really think we should let everyone that solved at least 20 bits go in.
Right. Right.
So just for clarification, even if you don't send a 0, if you sent 20 and you returned 18, that would be possibly acceptable, you're saying?
Yeah.
Okay.
Possibly,
Especially if in those 5 seconds that now I'm not under attack anymore and I'm okay, sure, I'll let somebody in.
But, just a clarification, if you receive you receive a response and you say, well, it's too low, so do you drop that packet or do you keep it in memory, or because otherwise if you say it's going to be handled, because in order you have to first to check the number of 0 and then you decide what you do. So when you put that into a low priority, you still keep that in memory.
So that is in terms of a really short-term queue or short-term list of things that you get evicted out of pretty much immediately.
Okay.
Or you could assign a random chance to either be accepted or not accepted, and not have a buffering at all.
Or you can just have, list of 100 best you have reached this point. And then when you get one and you see that, okay, this one has more bits than the 100th of there, so you actually insert it in the correct place list and throw the last one out. So you just have a big fixed amount of those. Because, 100 is enough if you are going to take, 10 milliseconds. Every 10 milliseconds start calculating, you can take as long queue that you can process in that time anyway. So.
Okay, next. So that's the first kind of attack, an attack on the half-open safe. Assuming that you have your bot army, then you can always have them get the response, the IETF init response, and then create a packet that goes, an IETF request. Now, the IETF request is supposed to be encrypted, but encrypted is just an encrypted payload and some jumble after that. To actually understand that it's not a real encrypted payload, you have to complete the Diffie-Hellman exchange, generate the keys, and only then can you calculate the MAC and see, oh, this is really not what I was expecting. So this kind of attack costs really nothing for the attacker, just generating some random noise. And on the other hand, it costs the responder quite a lot in CPU power by sending those invalid garbage. Now, it could be done it could cost the responder even more if the attacker actually does complete the Diffie-Hellman exchange and sends a properly formatted message that includes an invalid credential. We feel that because this is very costly to the attacker, it's probably not what an efficient attacker is going to do. Okay. So, if puzzles were used in the IETF init, then the responder could also give the initiator a new puzzle to make the attack of garbage and IETF request, to make that also costly. So the responder in this case includes the end puzzle in the IETF init response, and we've already had that. And the puzzle notification contains the algorithm, PRF, to be used in the puzzle, and that's selected from what the initiator had in its SA, IKSA init SA payload, and the difficulty level. Next. And in the ICOF, the puzzle is slightly different. So given the PRF, the responders, we already have the responders nonce, the NR, and this time we didn't have a cookie because we didn't need a cookie. Exchange, the IKSA init exchange has completed, so there was no cookie. Well, there was a cookie. Maybe there was a cookie. We have the responders nonce, and we have the responders SPI, IKE SPI. So we want to find a key K such that PRF of K with the concatenation of the responder nonce and the SPI and the responder SPI contains the requested number of trailing 0 bits. This is kind of the same puzzle, but this time carried as part of the ICE-OFF exchange. So such a constructions allow the initiator to reuse the same puzzle for both the unfragmented and fragmented ICE messages in case we're switching on ICE fragmentation. Okay, so when the initiator solves the puzzle, it returns the solution in the PS payload outside of the SK, outside of the encrypted payload. So we have the header, the PS payload, so that the responder can validate it before doing the whole Diffie-Hellman thing. And then we have the encrypted payload with all the IDI, search, etc., and whatever else. This allows the responder to verify the solution before it spends a lot of CPU on calculating SKey seed and SK something keys. So now the responder first verifies that the solution. If the solution is okay, the responder computes the Diffie-Hellman shared key and all the rest of the keys. And if the puzzle solution is okay, but the payload fails to pass the ICV check, then the message is discarded. However, the IKSA is not immediately deleted, and the half-open IKSA is not immediately deleted, and the computed keys are cached because no point in recalculating them next time when the valid packet arrives. Okay. So responder strategy. The responder should constantly monitor peers' activity and resource consumption. Should always use the following countermeasures once denial of service or distributed denial of service attack is detected. And detecting, there's some text about it in the draft, by a lot of entries in the half-open SA or a lot of the kind of failures that we expect in ICOF. At first, try to use the stateless cookies. If that doesn't help, use the IKSA init puzzles, and then also the ICOF puzzles if the attack if the second kind of attack is detected. If that doesn't help mitigate the situation, then we stop using the 0-level puzzle difficulties. We set a hard bar, and the last resort is to increase the puzzle difficulty more and more, even knowing that at some point we're going to lock out the phones, allowing only the desktop computers to get in. The last kind of attack is after the IKSA is established. That's probably the newest part of the draft. The goal of the attack here is to force the victim to perform unnecessary work, like performing an endless amount of liveness checks, continuously rekeying the essays. Each one of those doesn't take, well, I mean, if you have a forward secrecy set, then yeah, even child rekeying is pretty onerous. You can create numerous child essays with either the same traffic selectors or other selectors. All these attacks are targeted mostly on CPU power, and though some of them can consume memory. Next. So the thing is that all these requests are legal. These are all exchanges that terminate successfully. And they're legal in the protocol, so the victim cannot just refuse to do them because some of them are probably real requests from real clients. So the amount of work is roughly the same for both the attacker and the victim, so the attacks are more likely to be distributed. There's no point in using one laptop to attack a gateway for that. So the attack could use null authentication. They're probably not interesting otherwise, because if one of your known peers is attacking you, there's probably some things that you can do. That. Okay, so countermeasures. One thing to do is never to increase the IKE window size above the default value of 1. That's pretty easy, and that at least slows down the amount of new child assays and new liveness checks that the peer can perform. And if the number on the counter on the IKE assay messages gets too high, you can always use temporary failure and no additional assays, or one of those fails to stop the amount of work that is emanating from a single IKE assay. And we can also introduce artificial delays, although artificial delays have the downside that you're increasing your memory consumption, because you have to keep the request in memory until your delay expires and you're going to respond to it.
I don't think actually the first one is very good at, recommendations to say that you don't increase the window size above 1. You can also do that, even if you have a window size of 10, you don't have to, process them all at once. You can actually slow them down, You can just say, okay, if somebody is sending me, constant request, I don't have to process them, as fast as I can. I can actually process everybody else, and when I don't have anything else to do, then I take the first one of theirs, and because they can't, even if your window size is 10, they can send you only 10 requests, and you don't have to reply them unless you want them. They will retry. They will send a retransmission packet at some point, but and if they time out, then they just go away.
These countermeasures are not really ordered. In the previous slide, they were ordered. This is kind of do it at whatever pace you want.
And one of the things, because you can only increase the window size, you can't. Only way to decrease is to do IKE key, which is costly operation. So when you start the operation, you usually when you start an IKE assay, you usually put the window size to suitable value, and you reduce it to actually cost you more. So that's why it might not be a good idea. And actually, I would think it actually would be useful to have most implementers supporting some IKE window size than 1 only.
Yeah, I mean, if a peer is attacking you from one IKE assay, deleting the IKE assay is also a good thing to do.
Brian Weiss. So the third one is the strategy that if they is a strategy basically to make them start over with the new init and opt exchanges, which of course will cause them to do a cookie again.
Yeah. Although, assuming they're legitimate, well, yeah, the null-auth has this property that you're letting everyone in.
Well, we're assuming they're not legitimate here, right?
Yeah.
Although,
when you send the puzzle request, you send that before you know who is sending. I mean, the IKE init.
Right.
So at that point, when you fix the level of difficulty in the puzzle, you don't know who you address this difficulty to. And if you have a computer or a phone, it's the same policy.
Yeah, there's no way I can give an easier puzzle to a phone without having some way for the desktop computer to pretend to be a phone and get the easy puzzle. Same way as they can pretend to not support puzzles and just return the cookie and hope that we're feeling kind to old clients.
Yeah. Channeling Valerie from the Jabber, but then request would consume more memory on responder than 1. And reply that, yes, it would, but of course, I mean, memory size is usually, depending how many clients you actually have, and also if, okay, you can set that window size to be 1 for the anonymous people and you use bigger for other, and then so on, or use very small number, these things. But usually it's, the CPU is more important than the memory. Memory you can just always, and you can always, drop the clients when you run out of the memory.
think there's usually something around like 10 kilobytes per connected peer. Okay.
I have a comment. Yaron Sheffer, why aren't we using puzzles in this case?
Can't say that we've thought about it. It was definitely not mentioned on the list. Probably something to discuss, but then because you can have several requests on the same microarray, if you didn't set the default value to 1, then it's a question of what do you do with the other requests while you're solving the puzzle for the first request.
Actually, one of the things we could do in there is to that when you seem to be getting too many requests, you could start returning them with the error, failing the request with new error message saying, solve this puzzle before continuing. And if I send 10 requests to you, all of them will fail with the same puzzle that I have to solve. When I solve the puzzle, then I can start over the request. I mean, it's just, temporary failure with saying that, oh, solve this puzzle. This actually would be something that could perhaps be added to the draft.
Yeah, I simply don't see a difference between the first 2 exchanges and the following exchanges if you're unauthenticated. If puzzles are good for the first exchanges, then why not? Yeah.
And Valerie is continuing that the puzzles are controversial thing. It's better to use more simple countermeasures when you can do it.
That's good fodder for the list, though.
Yeah.
Brian-wise, it seems if you're doing PFS with the new child essay, that would be a really good time to use puzzles, all right?
That would be what?
A good time to use puzzles.
Mm-hmm.
I think so.
Almost.
Almost. It's the essentially last slide.
Paul, sorry, I haven't actually read the latest drafts on this. Is there any text in the draft about the invalid KE and cookie and puzzle notifications and how we can avoid that we need to send like 2 or 3 packets back and forth?
There's text in 7296 that you first do the anti-DOS, the cookie, and only if the cookie is, when you're convinced you start sending them back to bring another KE payload.
Considerable.
But I'm sorry, I mean signaling that the KE was wrong so that you don't waste another round trip after you've solved the cookie. And because that's the same with the puzzles. Otherwise, if you have the wrong KE and then you solve the puzzle, then you still have to do another round trip just because you got the KE size wrong.
Yeah, but with cookies, with 7296, you do have the 2 round trips for the KE.
Actually, I don't think actually anything in there actually forbids you to send an invalid cookie invalid key exchange notification at the same time you send a cookie. It's just normally, it's the only examples there are. But you can have any notifications in any of the payloads anyway, and both of these are notifications. So if you want to make an implementation that sends both cookie and also say that, by the way, you are using invalid or wrong group for the key exchange, you are allowed to do that. If the other one actually acts on that, he can act on it, or he can just ignore it, make the cookie request and so on. He's wasting his own resources at that point.
It kind of complicates the state machine, but not very much. Yeah.
Paul, so just my question was, should there be text in the draft that explains this? Because there is text in the base RFC that explains the interaction of invalid KE and cookie.
Okay, we can add that.
So speaking of complexity, Yaron Sheffer, yeah, complexity discussions are usually do not lead anywhere, but there is some excess complexity here, I think. For cases when you don't like the initiator's response, why not simply fail it? Why have 3 options like accept it, fail it, or send some other puzzle? Just fail it and let them start again. I think that was mentioned twice actually. and then the zero value. If I'm an initiator, how am I to decide what my peers are doing and how I can be bigger and stronger and get in front of them in the queue?
Well, the thing is that we have very disparate initiators. Everything from mobile phones, well, maybe the IoT at some point, to really, really large servers. And the same puzzle level cannot fit them all. Puzzle level that
Granted.
would take 10 seconds on a phone can be solved in microseconds on a server. And we have to give the phones a chance to connect.
I don't think we're giving them a chance. I think no matter what we do, desktops will have the upper hand if there's enough desktop to swamp the responders.
Brian Wise. So I first thought that zero was kind of silly, and then I started thinking about it as an economic model, and it doesn't solve the problem Yaron was just saying, but I guess the only really value of saying get as many zeros as you want is if there's an implicit promise that if you spend more time, I'll put you higher up in the queue and you'll come back. Okay, and I guess that still prefers PCs, as Yaron is saying. Also, do we have to do some computation first to find out that they've actually found a larger number of zeros, or do they return that I had forgotten? In other words, I'm asking is how quickly when we get the packet back, do we have to do any computation on it before we actually can tell, oh yeah, they actually
We have one churn
found more bits than somebody else did?
We have the key, so it's one churn of the PRF and counting the number of 0 bits.
So Tara, you're saying you have to do one hash? But then what the result of that hash is, what do you do then? You're probably just going to queue up and start acting on their packet, or I guess if you have a queue, you could put them farther up at that point. But anyway, the zero is like half the solution, I think. I think, and if we're worried about the phones, it doesn't really solve that. And I think there needs to be some more description on what happens on the responder side after, in order to prefer those that have calculated more zero bits.
I actually think we should actually not perhaps split the document, but actually make it have a two-part in it. One would be that it describes the actual protocol, meaning the payloads and that kind of things, which is required for the interoperability. So to be able to understand the PS payload, to understand the cookie notifications and requests and so on. This is something that is required for interoperability. Then we have lots of things that is implementation details. How do I want to wait for this long time and get all the requests there, then sort them using some heuristics, using I don't always sort them in exact order. I use some randomness. So even if you have a very slow device and you can only solve 3 bits, you have some probability of actually getting into the head of the queue because you were lucky. So all of these implementation details is something that actually implementers are going to be when vendors are writing the code, they're actually trying to make it as good as they can, and it doesn't affect the interoperability. It doesn't affect if your phone or desktop is talking to server, how the server actually sorts them doesn't really affect and how well that code is actually going to be working is one of the benefits for that. The vendor can say my code is best, so it's buy my product because that's the best code that you can have. But so it's actually something that we don't have to exactly define here. It's something that we can just give some guidelines. Okay, let's do that and that and that. But the actual things on the bits on the wire, that's what we need to actually specify.
So you'd like us to have where we describe the puzzles, say that if the puzzle is 20 bits and you returned 18 bits, then you have probability of entering, but not a guarantee, and all kind of things about queues and stuff. Put it in some implementation advice separate section.
Yeah, even over on appendix or something
Or
like
just,
that. Such having it's an informal appendix which gives you some kind of recommendations what kind of things, but it's not exact algorithms because you might make your much better algorithm than we can actually do here.
Sure.
Paul Hoffman, No Hats. Two things. Chiro gave a fairly clean split of protocol and then implementation suggestions. However, with the zero value, the client side of that actually goes in between both, because we have to say you have to return something in this format, but if you want to look better, do this many more. So I think everything else falls fairly clearly if we keep the zero. Everything else falls fairly clearly in, but that one we'll have to decide. And then a quick bit, I don't want to see appendices here. I think that's a completely wrong idea, because in fact the responder, an implementation of the responder really needs to make a lot of guesses inherently. There's nothing that we're giving them here that is just going to fix things. So I think that actually belongs in the main body of the document, but I think we can do like we did in the IKV2 spec, start with just some bits of what it looks like and then go to the others. I think putting an appendix is the wrong idea.
Brian against it. I'm fine with Tero's description. I wasn't asking to define what the responder should do or how he would prefer one over the other, but I think it'd be good to have some implementation advice in there saying, by the way, if you sent out a zero, you should probably prefer the ones that have solved more bits coming back, or some other sort of advice like that to make it worth your while.
Valerie has sent already several comments. So the first one is, if responder figures out that the initer solved a relatively easy puzzle, but it took quite a long time, the responder could figure out that the initer is weak and give it more priority. And then the second one is, I agree with Tero that some kind of algorithm for responder must be in the draft. Actually, yeah.
So in the draft, but not in the same place that puzzles are described.
Something else that was discussed on the list but sort of fizzled is determinism. I still think that Scott's idea on making the calculation much more deterministic is worthwhile. It still doesn't solve the problem of mobile versus desktops. I don't think anything does. But when you have a sort of homogeneous pool of initiators, it lets you configure your systems better.
As long as we keep the puzzle the way it is, then we have to set the puzzle level by kind of the worst case. And we found that occasionally initiators get lucky and get a puzzle that is solved in a tenth of the time as the worst case.
So I think what Yaron was asking for is a way to determine for a given puzzle how long is this going to take. And so if there's any way we can say things that already have these zeros or whatever, or if not, maybe pre-compute 100 and rank them and take them out in, one of the things I thought of it was, while you're not busy, pre-compute 100 of the cookies of the puzzles, or 1,000 or whatever, and actually do them so that you know if this is an easy or a hard one.
Well, Scott Floor did suggest an alternative kind of puzzle that where the best case was like 90% of the time that the worst case took, so it was pretty homogeneous. It was 2 months ago, so I don't really remember the details, but it did have some downside in state on the server, if I remember correctly.
I don't think there was state on the server. It was a little bit more complex on the initiator, but just a little bit, if I remember correctly. So it's a bit more difficult to explain, to describe, and than what we have now. But I think the upside outweighs it.
Okay, I'll look into it again. I do remember that the puzzle solution was rather large. It included a lot of, about 16 big numbers.
On the variability, I think when your slide said that it could take like between half a second to 5 seconds, depending on the puzzle, that made me think that it's an interesting area of research to find puzzles that maybe also themselves are more deterministic on the timing, which led me to notice that this version of the payload still doesn't have a puzzle type sort of registry. There's just a hash type registry. So I think that would be a good idea. And then when somebody finds a good puzzle that is more deterministic. And also, the other thing is that if you look at your table, or however useful that is, given the variability, at the 19 to 21 bits or so, there's kind of it's the next fairly large, getting to the rising part of the exponential curve. It'd be nice to have something where the number of bits, maybe there was a better range of where you don't go from like 2 seconds to 9 seconds. There was some intermediate steps, and maybe a newer puzzle type would get that as well.
First channeling Michael saying that he likes my proposal, then Valerie saying, I think we cannot make puzzles deterministic given the diversity of computational power of different clients.
I'm sorry, say that again? We can't make it better because?
We can't make it deterministic.
Cannot.
Cannot, yeah.
Oh, we can make it deterministic. Okay.
Cannot.
Got it. Okay.
Is that the real cannot or the should not? Kind of cannot.
So you can't make it deterministic across CPU types and all that, no, but it seems like with one CPU type, you should be able to have you'd have a better, if your goal is setting a certain load on a certain set of clients, it seems like you'd have a better picture if you had a puzzle that was deterministic at a certain CPU level, et cetera.
Yeah, or it still continues that look at the puzzle as a lottery. Some are more lucky.
And that may be fine.
And actually, what we had there, one of the proposals did earlier was that, okay, we have this, do multiple lotteries, and then you actually, when you add them together, then you have a more deterministic time. But actually, that's one of the problems there is that it actually makes the responses very big, and of course we can use some kind of tricks to compress that, but it still gets especially in some devices, where you start to get fragmentation and so on, which we can't do in the ISA init, so it's getting hard.
One of the depressing parts is that the botnets are usually desktops, so they're pretty much the most powerful powerful initiators that we have.
You're running this part. You're running this part, so.
Any other comments? Okay, thank you, Yoav.
Plenty to do on the list. Yes. So the next slide set.
Yeah.
Gotcha.
But still, Yoav, can you please take these issues like one by one to the list and drive the discussion moving forward?
And if someone opens actual issues on the issue tracker, I personally like the issue tracker that the IETF has better than the one on GitHub. I know that HTTP BIS and TLS do use the one on GitHub. I don't really like it, but I could use either. An issue tracker would help us track things.
As far as I'm concerned, you can use either one as long as the discussion is transparent on the list.
And you can open up issues on the issue tracker,
Yeah.
or on GitHub.
Can anyone open an issue on the tracker?
Yeah,
I don't know about GitHub, but yes, anyone who has a login on the tools site can do anything pretty much on the issue tracker. And if you don't have a login, when you first go, I think it says login or get a login, and it's pretty trivial, and it's just a round trip. It's not like restricted to working group shares or anything like that. Yeah. No. No, you get. No, if you send too many, you get Henrik asking you why.
Okay, so this is about the Chacha 20 and Poly 1305 draft that I'm trying to get in the group. So we'll talk about the algorithms, the CFRG draft, the Ipsecme candidate draft, and then I'll get on my knees and ask you all to support adoption of my draft. So Chacha 20 is either a stream cipher or a counter mode cipher. The opinions are divided on this issue. Poly 1305 is an authenticator function, pretty much a universal hash. Both were designed by DJ Bernstein. Both have been reviewed extensively. So Chacha 20 offers a performance advantage. Now, we are talking about AADs, so I would have liked to compare ASGCM to Chacha 20 plus 1305, but I couldn't find very good, reliable numbers for that kind of comparison. On the other hand, on DJB's website has benchmark results for AS counter mode.
Which, of course, is quite neutral.
Actually, it is, because all those are submitted by implementations and run in the background. So the values here are in cycles per byte, or cycles per bit, per byte, I think. And they show a clear advantage on all of our interesting platforms, which is modern Intel being whatever has ASNI, and old Intel and ARM. Even Chacha 20 implementers got better in modern Intel as opposed to old CPUs. So the old Intel, don't remember the exact model, it's some kind of something from 2007. It was a core thing, but it's not like an old Pentium, it's a core something. So Chacha 20 is faster than AS counter mode in pretty much all of those platforms. It's very evident in the old Intels, a little less so in the modern Intels, but also importantly in the ARM platform. If we were doing ASGCM versus Chacha 20 plus 1305, the old Intel and ARM would still have the Chacha 20 with large advantage, but on modern Intel, the ASGCM would slightly edge the Chacha 20 plus 1305 by about 5 or 10%.
Does ARM have AES acceleration?
Nope. So they're running pretty much. ARM has something called Neon that is not on most phones, but is on most tablets, and that has some advantage for Chacha, but I'm not really sure why. Okay, so these algorithms were proposed to both Ipsecme and TLS, and the feedback we got in both groups is go to CFRG and get these things approved. So Adam Langley and I went and wrote draft IETF CFRG, Chacha 20 Poly 1305. It's kind of a mouthful. And now, NIST approved algorithms comes with the special publication, some number dash some other numbers letter, which contains pretty great documentation. It has the algorithm details, some logic behind things, pseudocode, test vectors, implementation advice. We tried to replicate that in the draft. We have all of that stuff in the draft. Next. So there have been 2 or 3 implementations done based on our draft. They, not sure they interoperate, but they do all solve the test vectors. It got a thorough review at CFRG. The AAD construction composition that was kind of different from what DJV did got a security review. It's also linked from the CFRG draft. Anyway, that draft is approved. It's now in the RFC editor's queue.
Do you have interoperability with pre-draft implementations?
No. The way that the AAD is structured is the AAD information is structured is a little different, so it definitely breaks interop with whatever is in Chrome now. And
no, I think Adam's already fixed it. What was in Chrome at the time?
What was in Chrome at the time, and what was in SSH, OpenSSH at the time. What was in Chrome was anyway squatting on identifiers.
Yeah, but for the algorithm itself, pre-AEAD, I mean, There must have been implementations.
Oh yeah, they're the same. We haven't changed anything in Chacha 20 or in Poly 1305.
And did you test it against something?
It's working in OpenSSH and in Chrome versus Google servers.
Okay.
Of course, Chrome versus Google servers are two of Adam Lange's implementations working with each other. Okay, so the draft is pretty simple. Just describes how to use this pair of algorithms in Ipsec. Early review in this group said that the group didn't want an Chacha 20 encryption function and Poly 1305 MAC function. They just wanted, you all only wanted the EAD, so I took all that part out of the draft. It also defines a new UI suite called VPNC or Suite C, where C stands for civilian, not government algorithms. Currently we have P256 for the key exchange and HMAC SHA-256 for PRF, so that's not really very civilian. It has been suggested to replace P256 with Curve 25519, which I'm sure we're going to have some draft proposing. If nobody else writes it, I will. As soon as CFRG recommends this for TLS, I'll just take the TLS proposed draft and pretty much copy all of it. And there has been another suggestion to replace HMAC SHA-256 used for PRF with Blake 2, but Blake 2 uses a lot of parts of Chacha, but I don't know, adding another algorithm, another primitive just to be a PRF looks a bit overkill for me, so I'm happy with remaining with HMAC SHA-256.
Steve Kent, BVN. Two observations. The civilian part here, and this is a really minor thing, but we should keep in mind that many industrial, at least several industry sectors, make use of FIPS-approved algorithms, and they do this for liability purposes. The argument being that because it's a standard, and this is not just in the US, so the financial services sector, more or less on a worldwide basis, makes use of FIPS-approved algorithms and frequently wants the implementations to be FIPS approved as well. So civilian, I understand the motivation of not government, but in fact there are a lot of parts of the civilian sector that would not, I think, be happy switching over to using this for other reasons, big pharma, things like that. Secondly, I'm sorry, did you want to?
Well, unless NIST has a change of heart, none of these algorithms are FIPS approved anyway.
Yes.
Yes,
So
that's my point.
That includes Curve 25519.
I'm just going to get to that one next. If the motivation for 25519 is performance, because the other part was performance, it turns out that's not a good argument anymore. Russ Housley and I chatted with NIST people at the beginning of this week, and they had one of their contractors go off and do an optimized implementation of P256, looking at the way the 25519 is done, and theirs does equally well. So the notion, so I wonder about the other performance comparisons as well. What happened was when somebody said, oh, go ahead and can we make this competitive with this thing which is blazingly fast, and people put their minds to it, the answer was yes, they can. So they'll be releasing that code shortly. So if 25519, if a motivation here is to do it because of speed, I think that is not really a valid justification anymore. But wait until the NIST stuff comes out. And that makes me wonder about ARM implementations as well. When people optimize code for a given platform because they're suitably motivated, you can do much better. I will testify my personal experience was that back in 1978, when I was a graduate student, we decided during the MIT Independent Activities period in January to do the best, well, the fastest DES implementation we could. And it turned out that our DES implementation then became for several years the fastest in the world because we were suitably motivated to do this. In fact, we actually sold it to a company, Unisys, at the time.
because they wanted to use it in their research labs when they need to do random number generation, et cetera. And you know, we had hand-coded this in assembly language, and it was blazingly fast. So we should always be careful when somebody talks about one algorithm being faster than another. The question is, who went ahead, did it for that platform, tuned it, and were they really especially motivated? And I don't know about, I'm not going to challenge the other ones that you talked about earlier, but having just talked to the NIST guys, Doug Montgomery and Sriram, about the 2.5 you're baiting. 519, I know that's no longer blazingly fast compared to 256.
Now I feel very old because I actually remember Unisys.
Actually, because we can't use curve 25519 in IC version 2, I don't think we actually should even consider it for a part of the user interface suite. And same for Blake, because we don't have a specification for that. And also, I think it actually, I hate the names VPN A and B and C. I would rather have some name that actually gives you, I don't remember which one is A, is it the AES or is it the other one? Which one is which? It doesn't really give you any feedback. Right. So I would actually, and I mean, having a C as a civilian is also, I think it should, like, okay, we have to find a 9, where this C comes, because it happens to be next.
Sweet JB.
So wait, actually, this,
yeah,
so this presentation is not to beat this down, it's to find out whether there's working group interest. So can we not do too much of this right now?
I was saying that I think we should move the user interface suite stuff out if it's there, and you know, just specify the standard algorithms, and then we can have a 2-page document to have the user interface, and we can postpone that until we have the curve and so on specified if we want to do that. And I think this is a good idea to standardize this Chacha and Poly 3305. I hate the names of those two, but that's
okay. So good. Let's not go into it then, Tiro. Okay.
The reason I put them
time here.
The reason I put them in the draft because I thought that we'd have an answer from CFRG long ago, but that didn't pan out.
Chin?
Yeah. Can I add to what Steve just said?
It's not really relevant to whether we take this work into the working group right now.
No, I just provide some information to
no, then let's not do that now then. I mean, I think that'd be a wonderful thing for the next SAG, especially if you have results.
I'm not going to argue anything. I'm just saying. So again, I'm Quinn Dang from NIST, just talking on behalf of my division, Computer Security Division. We received some documents and proposal claiming, you know, they have implemented the P25519 to be compatible or even faster than Curve 25519, but that has not been verified by my division. So so it's not a sure thing. So it's just a claim right there, but it's not been verified. So we don't want to claim it.
Okay.
So just
Steve can claim it. You don't need to. So at this point, what we, the chairs, thank you. I think, is there a last slide? I think it was like, please support. Okay. Right, so that's what I'm going to get to.
Yeah. So the TLS working group was supposed to be discussing adopting this equivalent document this week, but they ran out of time before talking about TLS 1.3, so they didn't get to this, although it was on their agenda. And they would like, they're still not, haven't confirmed it, to make this a should level algorithm. They considered making it an MTI, then said no, let's just do it a should in TLS 1.3. And in my opinion, this is the best algorithm that we have that has a good performance on the one hand and a good chance of wide adoption on the other. So please support.
Okay, so what we would like to do right now, we already asked for support on the mailing list. We got a couple of people who said that they, and by support, what we're saying is people who will review the current document, review revisions, and absolutely do a review during working group last call. If you're interested in this work happening, but you're not willing to do a review, we don't really need to hear from you right now. We understand that people always like more algorithms. What this really is a call for is commitment to review. Who here, if we start with this document and knowing that some things will change and we'll pull some things out, but basically to support this algorithm in Ipsecme, Who here would agree to, again, do at least 2 reviews, most likely 3, of the document? Please raise your hands. And I'm taking names. Tiro, Paul W., because I'm Paul H. Anyone else here committing to review? I'm sorry? I still can't hear you, Tiro.
Valerie?
Valerie, thank you. Right, but what we really need are reviews to make sure we got the bits lined up, that we're doing the right parameters and such like. And Michael, good. I thought he was still listening. Anyone else? Bummer. Apple guys, you're new, but maybe this would be a good thing for you to do?
I would love to, but I
can't commit.
Can't commit to it.
Okay.
So, personally,
Yeah.
yes.
But yet, and again, we know that, the working group has a long history of always wanting to have more algorithms. That's fine. That's not, what we don't want is to move it forwards and then have insufficient review and have it published, and then we discover on the 3rd implementation that something was unclear or worse, wrong. So we're trying to prevent that. Okay. The chairs will have a discussion with Kathleen next week about whether this is sufficient or not.
Yeah, how many pages is this draft?
It's not pages, it's actually how many equations are in the draft that we could have gotten something wrong on. I'm sorry, not the equations for doing, the implementation choices. Yeah, okay,
So this is only about AEAD in IPE. In IPC.
But we can cover different things. How many pages is it?
not long.
Okay, so maybe some other folks who aren't comfortable with the algorithms could review some of the text or other things.
Mm-hmm.
Just feedback is really important.
So we'll talk with you about whether that's sufficient or not for us to turn it into a working group item or not, if we trust that that's good enough. And then we'll bring it to the list as how we do that.
But does that change? Do we get any more reviewers just by acknowledging that not everybody has to review the crypto aspects of it, but you can review other aspects of the draft? Does that help? Anyone else?
I think we should have that on Germany so that we can ask if we can do it.
Yeah, we'll do that again. We did.
6 pages.
Yeah, this is short. Paul?
I just wanted to note that there's at least 2 implementers on the list that you just gathered. So that's quite a good review because they'll actually write code.
Right. So that will actually be of help if you say, and I've done an implementation, God forbid, interoperated on a private value. That would actually make me feel better. And again, this is not like, oh, we're going to make a mistake. We've actually, in this working group, we've done very well on not having mistakes. In fact, probably the worst mistake that was made on any algorithm stuff that we've ever done was by our AD, who didn't ask us, of splitting out, having 3 numbers for trying to combine AES 128, 192, 256 as a single code point with a value. That's probably the only thing we've really done wrong, but I just want to make sure we don't blow this. So, okay, we want to move on. We will talk with Kathleen, we'll bring it to the list, and this may or may not then be a working group item. So Danielle? So this is a short presentation by Danielle on a draft that is not going to be in the working group, that is already in another working group, or will be, maybe?
Yeah, it is. I mean, it has been posted, but we had a 6-law security no.
Okay.
So
Yeah.
I don't know where it's going
So
to
this is not for this working group, but is definitely relevant to our work. So please.
Okay, so basically what we're trying to do is to make IPsec for also small devices. So we are, and small devices mean removing some unnecessary bits. So at that point, what we're doing with this one, we're trying to remove the IV from the packet and generate the IV on the 2 sides. So maybe next slide. Well, next slide. What you have to know is that what is costly for very small device is not the computation, but the extra bit you have to send. So next slide. So in the draft, I take care of all the AES modes, AES CBC, CTR, CCM, GCM. And the main idea is generate an IV that respects the different properties of each of these modes. And then you have to be able to derive this IV from each incoming packet. So next slide. Next slide. Oh, okay. So basically how it works, we take care of the sequence number, and we have 0 and the sequence number. So, well, the questions are now about the CBC mode is that do we have enough entropy? I'm raising the question I received from, well, someone in the room actually. And and the other one is about all the certification, how it is. So I read from the mail Steve sent that generation of the IV is not recognized by the FIPS. So, but at that point I'm ready to remove the CBC, AES CBC, because the others, well, the IV is determined in a deterministic way. So maybe that, if that helps, I mean, Carol.
I would get rid of the ASCPC completely.
Okay.
Mostly because, I mean, all of the small devices, they usually have using ASCCM for the hardware stuff, for the, hardware link layer anyway. So they're not going to be using ASCPC, and there's just going to be problems with the ASCPC because you don't have enough. Because the issues which might have, so it's easier to just remove it completely and only define it for others.
I agree.
Steve Kent, VBN. I want to clarify what I said about, that shows up, I think, is second bullet here. What I did in a message, and in fairness to Daniel, I just got around to sending him the message earlier in this session, was citing parts of the FIPS documents that say for the modes in question, not looking at CBC, the process that generates the nonce or IV is within the evaluation boundary for the algorithm. So the implication of this isn't that you have to send it with packet. It's that if you're managing the sequence number and extended sequence number in your IPsec implementation, that just became part of the algorithm evaluation. And so if you're looking at Internet of Things, and if one of the examples, for instance, is I'm going to use this in my electrical distribution system, again, from a liability standpoint, if I were in the power distribution business, I might say, I do not want to get my butt suit off when bad things happen because I didn't have an evaluated FIPS standard algorithm for this, and generating the IV in the fashion that Daniel's proposed would require that evaluation boundary get much bigger. And for instance, the chip that you could buy today that does AES, that warranty just got voided when you chose to generate it in this fashion. So it's just an implication for the implementations themselves and whether or not you think people who care about this will care about that aspect, because it's expanding the boundary. It doesn't mean you can't do it, but then touch any bit of code in there, voids your certification, you got to go back again. So people always try to get that evaluation boundary to be very small, and this is a problem whenever we have looked at this in the past. And we've looked at this in the past several times.
So this should definitely come to 6LO if it gets adopted in 6LO.
I think so. And I've provided Daniel with the citations of the text. And we actually went to the people at NIST in the crypto module validation program because someone said, oh, no, that's not true. Look at all these certificates that have been issued that said IV done externally, blah, blah, blah. And the crypto module validation people said, oh, we should change the wording on our site about this because it's misleading. That's not what it meant.
So again, I don't want to argue CMVP stuff here because they do change their mind at times, especially when shown sanity and stuff like that.
I have a question for Steve. Steve, is this only for CPC or if it's also for the CCM?
It's actually for counter mode and
because when I have looking at on most of these small devices, the counter management is always done outside. It's actually done by the upper layer, and it's actually how they store it and restore, which means that the whole device, if they want to have their small devices FIPS certified with for the crypto model, they actually have to certify the whole thing
Right.
anyway.
But again,
so I don't
not,
think it
not
actually
for here,
matters.
not for here. And I think this is actually, we haven't done it in a while, but I would propose to Kathleen that talking about FIPS certification at a SAG might be appropriate again at some point. Because these issues come up. I mean, again, this Danielle's is not for our working group, but these kind of issues sometimes come up with people saying that won't work with FIPS certification or that will. So I think having that happen again, maybe not in Prague, but maybe a little bit later, to have a presentation from the FIPS people on that would be good and would help reduce all of our time, because we are almost out of time now. So. Yeah.
However, I would like to hear if there are any comments as to the security of the proposed mechanism.
Right. So if we have any on the security of this, either right now or on a little bit on the list, but mostly it should go off to 6LO.
So just to clarify, the only IVs that you propose not sending are the ones that are, let's call them well known, like counter modes, where there are counters. You're not talking about basically moving the PRF into the kernel?
Oh no, well, the draft is only about the IV. I said
Yeah, no, I know it's ESP IV, but if... Oh, never mind.
Okay, so we still have 3 minutes or less. No one had asked for any more agenda time. I'm sorry, Kevin, did you have something? Or Kevin, did you want to do an agenda item? I just wanted to go over that. Oh, okay, fine. Okay, so thank you. Blue sheets are at the back in case you didn't sign them. Anyone want to share a taxi to the airport in about 3 minutes? Okay, let's do it. Go. We could do the train, but at this point, there's no traffic near the airport, so. And I got a free taxi ride on the way out.
So I'm actually going to experience Dallas by weekend.
Yes. Oh, so can you turn in the blue sheets, which means take them to the front, and can you tell them that this, I don't think that this belongs to AMS, but this was on that, and it's not mine. I put a label on mine. So if it belongs to AMS, great, and if not, they should have one. You know, when someone says I have a Mac and I didn't bring one, AMS loves they bring they bring the equivalent of a first aid kit for presenters. So great. Thank you.
Thank you.
I think this was more useful than I thought it would be. So.